about to do some stick welding here, and what you hear is the fan blowing. And one of the things I like about stick welding is you can blow a fan on it and blow the smoke past you. You don't have to breathe that stuff. MIG welding, you're going to blow your gas away. TIG welding obviously is not, it's a no-go. You can't put a fan up there. But I remember some of the jobs I worked, a fan was standard issue. It's so hot. You're welding down in tunnels and down in tight areas. You had to put a fan on one side of you, behind you, to blow the smoke away from you, and just to keep cool, because it was just 95 degrees at 6 o'clock in the morning when you went into the big concrete building. So I'm going to be blowing a fan across what I'm doing here today, and I'm not going to hurt it a bit. So that's one of the good things. That's why stick welding is so robust. Why you can weld outside. You can weld in a hurricane if you want to. So we're going to be using the PowerPro 256 combo TIG stick plasma cutter, and we're going to be using some 7018 1/8, and I'm going to be showing you a little bit of skip tech, or where to put the tie-ins when you're welding box tubing, square tubing to a plate or to something flat. And let's do it.
Alright, this is called backstepping, where you weld and then you back up and weld and tie in to where you started. So you have a tie-in on each corner and you melt in to the place where you started. So if you have a little bit of a stutter on a start, you can melt it all in, and all your stops are on the corners, and it looks good. It makes a nice, neat job for welding square tubing. It's a good way to do it, and it's not the only way, but it is a good way to do it. So last week we tried out the plasma cutter and left the torch on here, so I'm going to swap off the plasma cutter torch and put a stick welding stinger in here, and there's just not much to that. You just undo the high frequency pilot arc line and undo the Canon plug for the plasma torch control, and then turn the DINS connector and pull it all loose, and then wrap that up and then stick a stick welding stinger in its place. There's a couple different kinds of stick welding stingers and electrode holders, and this is kind of a newer version. And the handle cranks, and you put the electrode in the hole and then crank it tight, and it's kind of cool. It kind of feels cool in your hand, but in order to get an odd angle on the electrode coming out of the electrode holder, you just have to bend the electrode. And so, plus it takes just a little bit of extra time to chuck one out and chuck one back in. And if you're in a hurry, if you like to get in and out of a puddle real quick, this is probably not the electrode holder for you. However, it does crank down on an electrode a lot tighter than the old school style. And if you want to get an angle, you just have to bend the electrode if you want to get a certain angle. So I'm kind of old school. I like the old school type because a lot of what I do, a lot of what I've done in the past is pipe welding, and I like to get in and out of a puddle while it's still hot, so I don't have to chip slag. And this is just, I don't know, this is what I cut my teeth on, so that's what I like. Alright, changing from the plasma cutter settings to stick welder is pretty simple. So basically it was set on the far right here, that toggle switch is on cut, and I've got to go to stick. So press that on stick, and then I want to make sure I'm on DC, and then I just basically set the amperage, and there's not much more to it than that, really. Make sure all your pulsars are off and everything. I'm really not sure that matters. I haven't drilled down in the manual on this PowerPro 256 to find out all the little nuances of it, so I'm just kind of feeling my way through it. Now, 7018 1/8, this what I'm going to be using here, generally burns about 120, 125 amps good on flat, in the flat position. I wind up turning this thing up to about 145 to get it to run good, and every machine's different and every rod's different. Actually, one rod manufacturer to another can vary quite a few amps. So, it's there are rules of thumb, and then there's the real world. So once you can go to an electrode amperage chart and get a starting point, but if it seems too cold, don't be afraid to turn it up. That's what I did here. So I've got this thing clamped down, and I'm going to tack it on all four corners. Now I'm going to try to hit the corners while the tip of the rod's still hot, and that usually winds up giving you a good start. It didn't right here, so I get a file and I rough off the that slag, and then that gives me a good start. And then I was able to grab the fourth tack while the electrode was still hot on the tip, and didn't have to chip it. All right, so now here's the sequence. Starting on one corner, welding all the way to the other corner, and then when you're done with that, you back up. I mean, there's always more than one way. You could just weld this thing all the way around. You could weld it and tie in, swap rods, light up, tie in to each corner, and just if you're good at tie-ins, that works. But if you stutter, this technique I'm showing you is better, because what happens is you can, if you get a little bit of a poor start, you can make up for it by burning that start in once the rod gets going. And what I mean by that is because you're always welding to the previous start that you made, by the time you get there, the rod's good and hot, things are good and hot, things are going good, and then you can melt into and tie into that start and make a nice neat tie-in on each corner. So what backstep welding is instead of welding in series, you're actually welding in one direction but then backing up and then welding to where you started. So it works good on thin sheet metal, it works good on lots of things. Now 7018 is kind of a drag rod. You don't have to do any kind of manipulation. Some people like to make small little circles or a U shape. You don't really have to do anything but just drag it. And I like to have the machine set hot enough to where I can hold a really close arc, to where I can basically feel the tip of the rod scrubbing and it still won't stick. So I can just basically I can relax and I can let that tip dig in and just roll right along, and then all I have to do is, I don't have to worry about arc length. All I have to worry about is watching the toes of the weld for undercut, and keep the size of my weld the same, keep my travel speed the same, and all that stuff, and I wind up with a pretty uniform weld if I do all that stuff right. Now that was a start where I kind of missed, but then what you want to do, I wanted to start about a ½ inch, but it just slipped and it came about an inch ahead. But as long as I'm re-welding over top of all those arc strikes, that's okay. So you always want to strike your arc in a path that you're going to weld over top of your arc strikes. Arc strikes are bad. They will fail you out on a welding certification test. They look bad, and they actually are a problem, especially on high-strength steels, because they're a stress riser, and a crack can start where an arc strike is, because what happens is arc strikes usually are very hard and brittle because they heat up and quench so quickly. So when all this weld is all cleaned up, nice, chipped, slag chipped and brushed off and everything, you can see why I recommend the technique. A tie-in is on every corner. It just makes for a nice, neat looking job. It works. That's the biggest thing. It just works. Now, if this were 10-inch box tubing, you may not actually be able to even make it from one corner to another and have to make a tie-in in the middle. But it's 2-inch, so it's easy to burn a rod and make it from one corner to another and only have tie-ins on the corners. Now here's some thicker metal, some 1-inch welded to some 3/8, and that's after I got the machine set a little bit better. You can see that 7018 slag just peels right off, makes a really nice looking weld. That's what you want. When the slag peels off like that, it's a pretty good indicator you've got things set right. So that's the Everlast PowerPro 256 stick welding. Thanks for watching, and please visit weldingtipsandtricks.com. I do have quite a few t-shirts left. It's got a hog on it holding a TIG torch in one hand and a MIG torch in the other, and it says Down and Dirty, weldingtipsandtricks.com. And what's better than that?